Okay, hi everyone. So in this question, we have a particle P that moves along the x-axis, and basically we're given the formula or its velocity in that x-axis as v equals to 2t squared minus 14t plus 20. Okay, so looking at the first question, it asks what are the times when the particle P is instantaneously at rest. What this means is when it's at rest, the velocity is equals to 0. Okay, so therefore if I were to equate 2t squared minus 14t plus 20 equals to 0, I should be able to solve for the roots. Plus 10 equals to 0, and so I actually have two roots, and one is going to be 2 seconds and the other 5 seconds. So t equals to 2 seconds and 5 seconds. So what that means is we have a quadratic graph that intersects at t equals to 2 seconds and t equals to 5 seconds for the graph of velocity versus time. Okay, so we know that it's either going to be a minimum or maximum. One way we could test it is I could actually substitute the value of 0, and we know that the graph is going to intersect the value of when v equals to 20. So evidently this is going to be a minimum quadratic graph. Or I can actually prove it. So what I can do is I use my differential. So let me differentiate the velocity versus time. That would give us 4t minus 14, and what we then do is we can actually solve for that turning point. So when dv per dt equals to 0, so meaning when 4t minus 14 equals to 0, we actually get t equals to 7 over 2. 14 over 4 is 7 over 2, or equals to 3.5. And if I were to do the second order differential, so d2 v per dt squared, I actually get a negative value. So this means that my graph will be a minimum graph. Okay, so it asks us in that interval of 0 to 4 seconds, so somewhere midway until here, 4 seconds. So it asks what's the greatest speed. So I probably need to check for the speed at the turning point at 4 seconds and also at 0 seconds, okay, just to see which one has, in terms of magnitude, the highest value. So we already found at t equals 0 is going to be 20 20 meters per second. Okay, so so we know at t equals to 0, v equals to 20 meters per second. So at the turning point, t equals to 3.5 seconds. V, if you were to calculate out, it's actually going to be equals to negative 4.5 meters per second. What you need to do is substitute this 3.5 seconds into the v equation, okay? V with relation to t. Same goes with the 4 seconds. So when t equals to 4 seconds, so I've calculated earlier, that v that we get is obviously the magnitude is not going to be greater than 4.5. What was calculated out was 4 meters per second, negative 4 meters per second. So therefore, the greatest speed based on this interval from 0 to 4 seconds, that would be this 20 meters per second. So based on that interval from t between 0 to 4 seconds, the greatest speed, V max, is equals to 20 meters per second. Okay, so now for the third part. So in this question, you have to be careful. It asks for distance. So do be aware the difference between distance and displacement. So in our velocity versus t graph, if we were to integrate from 0 to 4 seconds, we will be including the positive area and also the negative area. In that case, that integral will actually give us the displacement. But if we want to consider the distance, you need to consider the positive value of this region and also the positive magnitude of this region. So in order for me to do that, I need to integrate from 0 to 2 of the function of the velocity 2t squared minus 14t plus 20 with reference to time. And normally if you were to integrate from 0 to 4 seconds, the addition rule is you would add 2 to 4 seconds on this other part. But remember I told you that we want to get the positive value of this area, so I actually need to minus it out from that. Okay, so the same function of this velocity, unfortunately I'm not going to write the full because it's a bit tight on space, so I'll just write it as this. So okay, as I repeat again, if I were to do the normal integration from 0 to 4 seconds, I will actually do 0 to 2 plus 2 to 4. But as I mentioned, this part of the expression will actually give me a negative area. Hence, I'm actually going to minus off that area. So we know that the integral is going to be 2t cubed over 3 minus 14t squared over 2 plus 20t. So we need to sub in the values of 2 to 0 from here. Sorry, 0 to 2. And same goes with this. So it's going to be the same integral, but in this case you substitute 2 to 4. So minus this value. If you were to calculate with a calculator, you should get the value of 24 meters.